So the equation y equals to 1 over x or y equals to minus 1 over x are reciprocal functions. Are reciprocal functions. So this is what we mean by reciprocal. You remember I asked you last week that what is reciprocal? Reciprocal means 1 over. So these are examples of reciprocal function. Is that clear? Now, they show inverse proportion. They show inverse proportion. And that was why I asked you that did you offer economics when you were in school? And you said no. I remember I gave an example of demand and supply, increase in price, and so on. Is that clear? Then I also remember I gave an example of wearing a heely shoe that you need to exert more pressure before you be stable. You get that now? So I want you to write this. Hope you are writing.
Yes, sir. I'm sorry.
Good. So reciprocal graphs are asymptotic in nature. They are asymptotic in nature. Reciprocal graphs are asymptotic in nature. Now, what do we mean by an asymptote? They are asymptotic in nature. So what do you mean by an asymptote? So I want you to allow, to write this so that we can now discuss what an asymptote is.
Asymptotic.
Asymptotic. Asymptotic. So when I don't write in, let me know, please.
Yeah. We're finished right now, sir.
Okay. So asymptote Asymptotes are lines. Asymptotes are lines. The graph approaches. Lines the graph approaches, but never touches. Is that clear? Asymptotes are lines that the graph approaches but never touches. I'll give you an example now. If I have something like this, now suppose I have the X and Y coordinates, and I have graph like this. The graph is tending towards touching X-axis and Y-axis, but it will not touch it. So this is an asymptotic curve. Do you get that now? An asymptotic curve. So this is what I mean by asymptote. You can see the line is tending towards Y-axis here, and it's not touching it. It's also tending towards X-axis here, and it's not touching it. Do you get that now? So that is what we mean by an asymptote. So asymptotes are lines that the graph approaches but never touches. So the question now is, how do we determine the point where a particular curve or function will be asymptotic? We'll see that later. But I want you to sketch this. So when you're done with that, let me know.
Yeah, done, sir.
All right. Now, I want to ask you this question. This function, the functions y equals 1 over x and y equals minus 1 over x are undefined. Are undefined. When what? Look at this function. 1 over x and minus 1 over x. When is the point where they will be undefined? Are you there, Ade?
Yes, sir. I'm here, sir.
Yes, when would they be undefined? Or maybe I should ask this way. When do we say a rational function is undefined? If you don't know, let me
Simply
know
be
so that
undefined. It continues on.
it's undefined what?
Yeah, I can't.
I didn't get that.
Oh,
You are breaking. When do we say a rational function is undefined?
they what is it? When it doesn't touch the X, Y axis, isn't it?
No, no. Do you have your calculator with you? Do you have your calculator with you?
I have a calculator, not my usual calculator. Yes, I have a calculator, sir.
All right. Now press 2 divided by 0. 2 divided by 0 with your
Oh, so
calculator.
when there's no real roots. Or something like that. No
No.
errors.
Tell
Yeah.
me what your calculator says.
Math error, sir.
That's error. That means 2 over 0 is undefined. So an expression is said to be undefined when the denominator is 0. Do you understand that now? So this
Yes, sir.
expression 1 over y equals 1 over x or minus 1 over x are undefined when x equals 0 and y equals to 0. Why is this so? When x equals to 0 and y equals to, if I say y equals plus or minus 1 over x, I can as well make x the subject to become plus or minus 1 over y. Do you agree with that? Do you agree with that?
Yes, sir.
So I can as well do that. So that's
Yes,
why we
sir.
can claim that when x is 0 or when y is 0. So both are undefined. So let me write this down for you so that you pencil it down. A rational function is said to be undefined when the denominator is 0. So let me write that for you. A rational
Wait,
function.
sir, can I summarize? What is that? So is that the FNS?
Which one?
Wait, sir.
This?
Is the thing
This.
is it the what?
The
No, it's
functions.
above the Y. Yes, sir.
The functions.
Oh, okay, the functions. Okay.
Yes. So a rational function is undefined when the denominator is 0. So a rational function is undefined when the denominator is 0. Can I move on?
So you're going too fast. I can't see. I haven't finished
Oh,
what I'm
okay.
writing
Okay.
previously.
Let me move it up. So when you're done, let me know. Let me load it. Take the other line here. You should be done writing this.
Yeah, I'm writing the new stuff you wrote, sir.
So when you're ready, please let me know.
Okay, don't finish writing, sir.
Okay. So because of what we have said now, that is going to be asymptotic. I mean, it's going to be undefined when x is 0 and when y is 0. So that means y equals plus or minus 1 over s is asymptotic when s is 0 and y is 0. Is that clear? It's asymptotic when s is 0 and y is 0. So that now suggests that the graph will look like this. Then the line of symmetry will be here. So this is line of symmetry, y equals x. Then the graph is y equals 1 over x. That's the graph of y equals 1 over x. Then for the negative, the negative is going to be like this. And that's going to have a negative slope, be symmetrical at y equals minus x. And this is the graph of y equals minus 1 over x. Is that clear? The dashed line
Yes,
are,
sir.
what do you say? The dashed lines are lines.
What was that, sir?
Can you hear me?
Okay.
So the dashed lines are lines of symmetry. Lines of symmetry. Hope you still remember what we mean by line of symmetry. That means at that point, you can divide it to two equal parts. In other words, they are turning at that point. So when you're done with this, let me know. When you're ready, let me know, please. No, cover it.
Okay, so I'm finished writing.
Okay. So I want you to take note of these remarks.
Yes, I've taken notes of it.
Remarks. Number one. A reciprocal graph has asymptote where the function and alaja tó ti gbé ni. Sorry, I want to quickly pick a call, please. Write while you wait for me.
Yes, sir.
Yeah, sorry, I'm back. So I said a reciprocal graph has asymptote where the function
Wait, so
is.
is there going to be a P in the asymptotic?
Yes, when you say asymptotic, when you say asymptote, you are correct. Both are the same. You get that now?
Oh, okay, so the same. It's the same sentence.
Yes. So you may put it this way that a reciprocal graph is asymptotic where the function is undefined. But you can see the way I've constructed it now. I say a reciprocal graph has asymptote. Do you get that now? Where the function is undefined. Or you say a reciprocal graph is asymptotic where the function is undefined. You are saying the same thing. Does that make sense to you?
Yes, so it's S Y M. Is that T or P?
Where? You mean here?
S Y M. Is that P or T?
T.
No, sir. The asymptote.
The asymptote,
T. Okay.
yes. T-O-T-E. A-S-Y-M. Oh, there should be P. There should be P here. There should be a P here. Yeah. So asymptotic. Asymptote. So you are saying the same thing. Now, you need this statement to solve problem. Am I communicating? A reciprocal graph has asymptote where
Yes,
the
sir.
function is undefined. We'll use that to solve problem. I'm going to give you illustration very soon. Now, number two, the function y equals 1 over x minus a plus b, x minus a plus b, has the same shape, as y equals plus or minus 1 over x. But with different asymptotes. Do you understand that now? So what we are saying is that if I sketch the graph of this, it's going to give me the same graph as this. Let me go up. Let me go up to the previous graph that I showed you. That is, this graph is going to look like this. It's going to look like this. You're going to approach X and Y in this regard. Do you understand that now? But the point where the turning will now occur is what will now differ, which is the next thing we are going to see. Do you understand that now? So this graph and this one, we have the same shape, but
Yes, sir.
the different points where the turning will lie. Do you get that now? Different line where they tend to approach, but the same shape, pattern of shape. Is that clear?
Yes, sir.
Okay. So when I don't write this, let me know when you're done with this.
Yes, sir. I've copied this down.
Okay. So the next thing we'll now do now is how to determine and sketch how to determine and sketch an asymptote. How to determine and sketch asymptotic curves. How to determine and sketch asymptotic curves. Now, for instance, I will say determine the vertical and horizontal asymptote of y equals 1 over x minus a plus b. So that's the illustration I want to give. Illustration. This thing can wait. This thing can wait. So please write this quickly so that we can solve it together. When you have copied it, let me know, please.
Yes, sir. Why is that? What's that? How to get off my screen?
What do you say?
Oh, so there was like a gray box like in the middle of my screen that I couldn't see you get past.
Well, where is that? What's that? I said illustration here. So
Just like that with it.
what do you say?
Don't so I've dealt with it.
Okay. When you are done, let me know, please.
Yes, sir. Okay, done, sir.
Okay. The solution y equals 1 over s minus a plus b. Now, vertical asymptote is when x minus a equals 0. You can see that the denominator is here. So we are going to determine the vertical asymptote when this denominator here, x minus a, is 0. And that means that x equals to a. So that's vertical asymptote. Now, horizontal asymptote. You first make x the subject in, let me call this 1. Let me call this equation 1 in 1. So how do we make x the subject there? So y equals 1 over x minus a plus b will now become 1 over x minus a equals y minus b. Do you agree with that? You take this b to the other side, it becomes y minus b. Am I communicating? Are you with me?
Yes, sir.
Okay. Now, so I will now cross multiply or rearrange. I will rearrange this. When you rearrange that, it will become s minus a equals 1 over y minus b. Do you agree with that? This go to this side, this come to the denominator here. So from there, s will now be 1 over y minus b plus a. So I've made s the subject now. So the horizontal asymptote s horizontal asymptote is when y minus b equals 0, which implies that y equals to b. Hope that is clear. Yeah, please write that. Then I will now show you the sketch. So we have determined the point where the vertical asymptote will lie, which is A. We have determined the point where the horizontal asymptote will lie, which is B. Yeah, please write this. Then I will now, okay, let me show you the sketch here. I think I can put it here so that we just do everything at the same time. Now, let's have our X and Y axis drawn. Now, S equals to A. Let's assume A is here. This is A. So you're going to have your vertical line here. No, we said vertical asymptote. Can you see that? Then Y equals to B. Let's assume this is B. This is B here. So you have a horizontal line here. Hope I'm communicating. Are you there? Hello?
Yeah.
Okay. So the asymptotic curve will now go this way. Can you see it? So this is graph of Y equals 1 over X minus A plus B. Does that make sense to you? So this is what we mean the other time, that the graph or the curve, we have the same shape, but at different points of asymptote. That's what we mean by that. So please copy and complete this. Then after that, I will now give you example. When you're done, let me know, please.
Yes, sir.
Easy. So let's see example now. Example. The question says, sketch the graph of Y equals 1 over X minus 2. So solution, Y equals 1 over X minus 2. I will use this to determine the vertical asymptote. Vertical asymptote is X equals to 0. Can you see that? Because this is the rational function that I have here. So, and that will be undefined
Yes, sir.
when S is 0. Hope that is clear. Now, horizontal asymptote.
Yes, sir.
So for the horizontal asymptote, make X the subject. So that will be y plus 2 equals 1 over x. Do you agree with that? If you take 2 to the other side, so it will be y plus 2. Then rearrange it, so that will be x equals 1 over y plus 2. So the expression on the right-hand side will be undefined. The right-hand side will be undefined when y plus 2 is 0. And that implies that y equals minus 2. So the horizontal asymptote is when s is minus 2. So the graph will now look this way. I want to move up a bit. So we now have the x and y axis drawn. Let me use something that will make it smooth. So we have x, y. Now, vertical asymptote, we said it's going to be at 0. So that means we are going to have it on this line. Let me use another color. Let me use another color. Let me use blue, dark blue. So the vertical asymptote is going to be on this line. Sorry, it's not straight enough the way I want it. Okay. You get that now? Now, the horizontal asymptote, we said is y equals to minus 2. So this is y minus 2. So the horizontal asymptote will now go this way. Is that understood? Coming. Let me erase this 2 here. So you have minus 2 here. So this is the point of minus 2. So what does that suggest? Suggests that the graph will now go this way. Sorry, I want to change the color. So the graph will now go this way, tending towards touching that blue line on the vertical, but it will not touch it. And it will go this way. And don't forget, we said it's going to be symmetrical at that point. So that means the other side will now be this. You tend towards touching this, it will not touch it. So this is the graph. So the blue lines are the asymptotic lines, the point where the expressions are undefined. That's the asymptotes. Understood? So you now label it graph of y equals 1 over x minus 2.
Yes, sir.
So that's it. So copy that quickly. If you have questions, please ask me.
Yes, sir.
So when you are done, let me know.
So she had to step out for a bit, sir.
What do you say?
She
Hello?
had to step out, sir.
Want to step out? I said,
No, my mom had to went out, sir.
oh, okay, okay. So I'll talk to her later then. So are you done with this?
Okay.
You have completed it, right?
Almost, sir. I'm writing down.
Okay. So when you're done, let me know. That's why I'm a guru below, man.
Okay, sir. Okay, wait.
You're done. So all right. So I'll be expecting your response. Then I will respond to the one mommy just sent later today or tomorrow. So bye.